Welcome to Math with Mrs. Bibb. Today we'll be learning about how to solve quadratics by graphing. Make sure to fill in your table of contents and complete your weekly warm-up as we complete it together in class. If you are absent, please make sure to do the warm-up that is posted on the PDF in Google Classroom. Here is the beginning of the notes, and we're using Student Journal, page 283. Please make sure to write down the definition of a quadratic equation, and then we will look at those core concepts. If we want to solve a quadratic equation by graphing, then we are going to first make sure it's in standard form. Make sure it equals 0. Next, graph the related function, and we are actually going to use Desmos to graph. I'll write that out in case you need to reference back to this. I encourage you to write that down, Desmos.com. You're going to find the x-intercepts. Now remind yourself what the x-intercepts are. The x-intercepts are where your graph crosses or touches the x-axis. Those are your x-intercepts. You're going to see this written in many different ways. You're going to be asked to find the solutions. You're going to be asked to find the roots. You could also be asked to find the zeros. Those are all the same thing. On a graph, it's where it crosses or touches the x-axis. Now, notice here it says, if any. If a graph does not cross or touch the x-axis, it does not have x-intercepts. So that means there's no real solution. In Algebra 2, you will learn what kind of solutions they are, but you will write down no real solution if it does not cross or touch the x-axis. Okay, so I want to just quickly sketch each of these scenarios. I'm going to call this Scenario 1, Scenario 2, Scenario 3. So in the notes section here, if you will please sketch what each of these would look like. The bell's about to ring, so I'll probably have to finish this later. But if your graph has two real solutions, so here's a graph. I'm going to go across and draw the graph for each one, just a coordinate plane. If it has two real solutions, then that means it's going to cross or touch the x-axis in two places. There are your solutions. If it has one real solution, then it just touches the x-axis in one spot. And if it has no real solutions, then it will not touch or cross the x-axis at all. Okay, just in order to help us save time, I went through to Desmos and I graphed each of these. Now, some of my graphs are terrible, so I made sure to pull up Desmos here as well. I don't know if I can manipulate that around. Let me see. Let me get rid of that little line I just drew. I'm hoping that I can. Okay, probably need the pointer. Yes. I would encourage you to go to Desmos.com. You can see it here on your screen. And that's what I'm going to do for each of these. I have the graphs drawn, and you can draw a rough sketch. I probably won't graph each of these because I want you to see how to do this. So x squared plus 4x. Now let me grab something really quickly. I did not point out that this needs to equal 0, and it does equal 0. But let me point out something really quickly. Make sure it equals 0. When I typed x, I hit this button. You can use your keyboard as well. To do square, you hit, I hit this button, or you can hit this one and then type the number 2, and then you tap beside of it to continue. And then I typed plus and 4 and x. And I'll show you again on another one, but I will have to finish this video later. I didn't re-listen to the beginning of this slide, everything that I said. I know I talked about how to graph and how I got the graph that's over there, but I don't remember if I mentioned what you're looking for here. To solve the equation by graphing, all you have to do is look at the graph and find the x-intercepts. So that's what I'm going to do here. I'm going to write down find the x-intercepts. You may want to do that as well. That's what you're looking for. And so the solutions for number 1, when I graphed this, I circled the x-intercepts, or I put a dot where the x-intercepts are. I want to show you what's really awesome about Desmos. It'll let me, it's probably going to reopen. Okay, and it made it go away. So x squared plus 4x. If you tap on the intercept in Desmos, it tells you -4 and 0. So my solutions are the x-intercepts. -4 and 0 are the solutions to number 1. So I'm going to write that in, and I put them here, -4 and 0. Okay, I'm going to graph number 2 in just a moment. I want to make it equal 0, so I'm going to do that first. I want to keep my squared term positive, so I'm going to add x squared to both sides. So 0 equals x squared minus 2x plus 1. And so then I can go back to Desmos. Maybe. And I can type in, okay, x squared minus 2x plus 1. And you can see that 1 is the solution, and that's the only solution. So I'm going to make this smaller, I think. Can I do that? Yeah. And move it out of the way. Oops. I'm trying to move it, I'm sorry. I'm struggling. I don't think I need to graph anymore. I don't want to move that. Oops. Maybe I can pick it up and move it. No. There we go. I just made it tiny. Now I can write. Okay, so my solution to number 2 was 1. And number 3, where does it cross the x-axis? It does not. So there's no real solution. Okay, I'm going to pause and I'm going to go through. Hopefully you can tell from my graphs, and I'm sorry if they're not very good. Hopefully you can tell from my graphs what the solutions are. So I am going to stop recording, and I'm going to go through and write all the solutions. If you'll pause, and you will write the solutions to the 6 that are remaining, and then you can press play again and check your solutions, or check mine to make sure I'm correct. Okay, I have the solutions here. For number 4, I got +1, +4, -3, no real solution because it does not cross the x-axis, -3, +4, +5, and no real solution. Let me go on to the next slide. Okay, it says to approximate the zeros, and actually it says if you have access to Desmos, you do not have to approximate. Let's use Desmos to see how well I approximate my answers. I encourage you to go to Desmos as well, as you will be using this website on your assignment. Okay, so I'm going to approximate first because that's what the directions say to do, but then I'm going to check them with Desmos. So forgive me if I'm a horrible approximator. My graph is going by ones. This appears to be less than halfway, so I'm going to say 0.4 is one solution. Oops, let me undo that. And then 3.7 is the other one. We'll see how well I approximated in just a second. 3.7. And then for number 17, negative 1.3. Because that looks like about negative 1.3. And then 1 to 2.2. And again, I'm just guessing. I really am. This looks 2 and it's a little bit past 2. We'll see how far I'm off. And then this next one, number 18, negative 1, negative 2, so negative 2.2. And then negative 4, negative 5, negative 5.7. Can't really tell that's a 7. I hope you can. Okay, so let me grab Desmos. Here it is down at the bottom. Let me grab my pointer. Make this bigger. I think we'll be able to see. Okay, so x squared minus 3x plus 1. Oh, hey, I did pretty good. That one's okay. 0.4 and not 3. Oh, 3's right there. See, you all probably knew I goofed up. And that's not a mistake. That was just me estimating, and I did a terrible job. Terrible, terrible job. It's 2.6. And I'm sure you noticed that as I said it, but that's okay. I was estimating, and I was very bad at estimating because 3 is right here. So I should have known that, and I hope you knew that as I was going through it and doing it. Okay, now let me go to the next one. Go back to my pointer. Okay. I need to erase that. X squared minus x minus 3. You grab an eraser and erase that circle. Okay, so negative 1.3. Hey, I did pretty good. That one's fine. And 2.3. So I'm going to fix that, make that 2.3. But that would have been fine. That would have been a good approximation because I wasn't too far off. And now I can't see that answer I have over there. I think it was 5.7. Well, I'll see in just a second. Okay, and the last one, negative, so I just put a negative sign in front. Negative x squared minus 8x minus 13. Okay, so here we go, moment of truth. Negative 5.7. Hey, I was right. We can't see it, so I'll just write down here. Negative 5.7. And then, let's see the other one. Negative 2.26, which would be negative 2.3. So that's good. Hold on, let's see. Oh, I got negative 2.2. So negative 2.3 is the better answer. Let me fix that. Negative 2.3. Those are the approximate solutions because it's not negative 2.3, it's negative 2.268. It's not negative 5.7, it's negative 5.732. Okay, let's go on to the next one. Okay, talking about what the x-intercepts mean, a real-world example. If my equation for a quarterback throwing a football was f of x equals x squared minus 5x, then I could tell you how many feet away from the football player would the football land. Because this is when, it's not really necessarily on the ground, but it sort of is. It would land, I guess it would be a little bit further here. So let me erase that because that's probably is right. If you're talking about, I know the football doesn't start on the ground, but this is like 0, 0, and then this is where it would hit the ground. So here's my equation of this football being thrown by the football player, and I'm trying to find where it hits the ground, which would be the x-intercepts, or the ground intercept. So I'm going to solve by factoring. We'll factor out x. And then I'm going to do the zero product property. There's the first x-intercept. That is represented here. And then the second x-intercept is represented here. So x equals 5. Now, the problem would have to tell you what the units are. So is this 5 yards? I really didn't know what a reasonable measure for how long it takes or how far it takes for a football player to throw a football. So I'm sure it's more than 15 feet if they're a very good quarterback, but I didn't know. So anyway, the football would be 5 yards in my circumstance. From the quarterback when it lands. You may want to draw that picture, just barely sketch it, doesn't have to be perfect. From the quarterback when it lands or when it hits the ground. Because this was an extra example, so you may want to put it in a spot where you have space to talk about a real world example of these quadratics, because we will encounter those. Okay, the last slide just tells you that we're going to be doing a linear transformations lab for week 31 part 1, and then this will be week 31 part 2. So I'm sorry these notes are so long. I hope you have a wonderful day.